Hey listeners, today we had on Sreeram Kannan from EigenLayer and Lucas Bruder from Jito. Sreeram pioneered the concept of restaking on Ethereum, where staked ETH that secures the network can be used to secure additional apps or services. Lucas is launching restaking on Solana with Jito. They get into why you should still care about restaking, whether protocols secured by restaking can actually pass on yield, and we get a little window into how Jito actually built restaking. There's a lot of brain cells in this episode, so it's time to lock in. We'll get into it right after this. Hello and welcome back to another episode of Lightspeed. I'm your host, Jack Kubanek, alongside Mert Mumtaz, and today we have a pretty fun episode. We're joined by Lucas, the co-founder of Jito, and Sreeram, the founder of EigenLayer, and we're going to be talking restaking, kind of a Solana, Ethereum restaking extravaganza today. Lucas, Sreeram, thank you for coming on the show.
Thanks for having me.
Thanks so much, Jack. Thanks, Lucas. Excited to be here.
So I want to just start off maybe a little bit general. Restaking is something that maybe if you trace the narrative significance early 2024, it was talked about a lot. A little less so nowadays, perhaps. It's just not in the crypto Twitter everyday eye as much. And so I want to give you both just an opportunity to speak again a little bit about what is restaking and what does it bring to your respective ecosystem. So Lucas, you're about to launch restaking on Solana over at Jito. So I'll start with you, and then Sreeram, I'll throw the same question to you, maybe with you might have a slightly different answer for what restaking does for Ethereum as opposed to Solana. But Lucas, beginning with you, why restaking on Solana?
It's basically just staking with a little bit extra flavor on top. The extra flavor being you can staking isn't anything new. Like proof of stake blockchains exist and have been around for a while. It's the one thing that I believe EigenLayer kind of added was this ability to apply it to multiple networks at the same time. I thought that was kind of interesting. And for us, the way I think about it is it's kind of a way, Jito restaking is a platform for applications and infrastructure to decentralize and have a lot of customizability on what assets are supported. And for us, the tip router is kind of the first instantiation of that to kind of decentralize the way that the MEV airdrop happens on Solana. And then there's a few other applications that are kind of building on it using, some are using Jito Sol, other LSTs, and then some are using JTO as well. So it's really just a path to hey, there's a lot of infra that runs, especially on Solana, and there needs to be a way to decentralize and secure these things, and adding support for tokens to do this seems like a pretty natural thing.
Does Jito's version of restaking work differently from EigenLayer's to your understanding, or are they pretty much the same thing?
Yeah, I can comment on how Jito restaking works, and then we'll let Sreeram talk about the way that EigenLayer works. The way, let's see, how do I like to go in the weeds. I'm going to try to keep it high level. It's something I'm practicing these days. But we kind of have, there's two kind of enshrined programs in Jito restaking, and they work together. One is the Vault program. It's kind of like a staking container. So that's where you create your VRTs or Vault receipt tokens. You can basically think of those as LRTs on Ethereum. And that's kind of the way to create a VRT. Just go through that program. It's permissionless. Anyone can create a VRT and start depositing. You can mint and burn assets in there. The Vault is also responsible for delegation. So you have a Vault manager or a delegation manager that you have all these operators, and you can basically delegate these assets across the operators. And then you also have the restaking program, which is where you register your networks. EigenLayer calls them AVSs. We call them NCNs for node consensus networks. It's kind of like that restaking program is basically a registry. So yeah, there's like a lot of overlap between those. The Vault program, I'm curious to hear how like the LRTs work on Ethereum, but we've kind of like made a canonical way to create Vault receipt tokens, similar to like the SPL token program, where there's like one token program on Solana. There's not like on Ethereum, there's like every token is a different contract. On Solana, basically every token comes from the same contract. You can kind of think of like the Vault program like that. And then some other like stuff that we added was the concept of like there's all these like mutual opt-in between all the parties involved. So you have like the operator, the NCN, and the vaults, and they kind of coordinate off-chain, and they store basically like the two parties opt in, and that's stored on chain. So like you can like have a totally permissioned operator set, or an NCN can like permission the vaults that stake to it. The vaults can like have like hooks to like add permission so only certain depositors can deposit. There's a lot of like customizability and basically control that you can have over your setup.
Okay, and so Sreeram, as you listen to Lucas's description of Jito and what it's doing on Solana, is that the same as you would describe what EigenLayer does for Ethereum, or are there differences you'd point out there?
Yeah, maybe I'll start a little bit from like why we started EigenLayer. We started EigenLayer with the thesis of open innovation. Open innovation is this idea that anybody who wants to build new decentralized services can build apps now on blockchains like Ethereum or Solana, right? That's the scope of open innovation, that anybody can come and build smart contracts on top of blockchains. And our thesis was that, many things that you cannot express as programs on top of blockchains can be expressed as services on top of decentralized networks. So we did not start from, hey, we have stake or we have any of that stuff. We started from, hey, I want to build new consensus protocols. I was a consensus researcher at the University of Washington. And we had lots of these different kinds of protocols, which each of them would perform different tasks, different goals, different trade-offs, all this stuff. And we needed a framework to express it. And that's really what EigenLayer was. Eigen in German for your own layer. Anybody should be able to build their own layers on top. So that was the starting point, and we started this project in 2021, July. And the idea, the problem is when you have an idea like this, where the core idea is anybody can stake, and you can bring stakers, node operators, and service builders together, so that stakers bring the money that promise that the service is run correctly. Operators bring the computational resources that actually contribute to running these many decentralized networks. And then service builders bring innovation, ideas, code that actually run on top of the system. So that's the overall protocol that we wanted to build. But the problem for us is, how do you get started? Like, you have none of the three sides. Like, you don't have a stake, you don't have operators, you don't have services. How do you get started? And the idea to get started was restaking. So EigenLayer is not a restaking protocol. EigenLayer built restaking to begin with. So what do I mean by that? So how do you get this whole ecosystem started? We get started by like getting the first side, which is stake, onboarded. How do you get stake onboarded? Already a lot of people are staked on Ethereum. They're onboarded there. Can we just like re-onboard them into like this platform? So that was the idea of restaking, which became like its own funny meme on its merit and helped us a little. So we went with it. But the idea of restaking is you stake in Ethereum. You're already getting some rewards. So the capital cost of like using that stake to make additional promises is not too high. So you can actually stake on top of EigenLayer. So then you start thinking like, how should restaking work, right? And we have two different ways of restaking on EigenLayer on Ethereum. The one approach is you can take a liquid stake token like Lido STETH and then deposit it into a vault and like that, and then like delegate to operators and services. Or you could just do something we call native restaking, which is so the thing that on the first modality, which is you have to stake an LST. Then what happens is anybody to participate in EigenLayer needs to have that LST, and and one of the things Ethereum is very careful about is kind of how to ensure that we don't force everybody into a dependency of a certain LST, or or in order to get additional rewards. So one of the things we did is on EigenLayer, we have this feature called native restaking, which basically is stake in Ethereum. You don't need to delegate to like anybody else or use an LST. You can set when you set your withdrawal credentials, which address is able to withdraw, it goes through the EigenLayer contracts. So when you try to withdraw, like your money will go to the EigenLayer contracts, and EigenLayer contracts will let you withdraw. So what that does is let us impose, staking rewards and slashing conditions on top of your stake without having to have any additional external dependency. So this serves both major institutional clients, like Coinbase wants to stake, they don't need to go through like some other LST that is run by a third party. Or BlackRock wants to have like their own ETF, they don't need to like have other stakers, operators, participants, they can control it. So that's what we call native restaking. So this is a special, whatever, Ethereum centric feature that we have. But like I said, we are not building fundamentally a restaking protocol. We're building frameworks for people to build arbitrary decentralized networks on top of our core frameworks. So that's how we think about it. Open innovation is our driving value, and we want to make it as easy to build services on top of blockchains as it is to build services on top of the cloud. So that's one of our like directional imperatives. So when you talked a little bit about in 2024, it was like a bit of a narrative and buzz, and it's not so anymore. I think it was a little kind of interesting to go through that, because I didn't know what the big narrative was, and we were at the center of it. But everybody's like, these things happen kind of on an emergent basis that we don't control, and just everybody's like over excited. The usual, like in any technology, you overestimate what can be done in the short term and underestimate what can be done in the long term. I think this is one of those things. It's going to take a long time to actually manifest a lot of these decentralized networks. We call them AVSs, like Lucas pointed out. AVSs we used to call earlier actively validated services for which actually need to sit and run active validation. We are thinking of renaming it to autonomous verifiable services. Autonomous, they run on their own. As long as anybody has the stake, they can come and stake and keep running it. Verifiable, if you don't run your service correctly, you'll be held to account. Services, right? So that's our category of what we're calling things built on top. They're autonomous verifiable services. And who's consuming these autonomous verifiable services is consumed on chain, right? So it's usually like some app or like some dApp on chain calls an AVS runs and provides some computation or results or whatever, and then those results are brought back on chain. But the thing that initially we started with restaking, and then we've now moved on to you can stake arbitrary assets, other things on top of it. So that's where we are on our evolution there.
Yes. I do want to, on your point about the kind of narrative of restaking, I reached out to Kaito AI, who's big for their yapping thing these days, but just asked them to pull some data on like restaking as a narrative. And in like February, March, restaking or LSTs, so liquid or LRTs, I guess, liquid restaking tokens, had over 3% of mind share. Today, that's under 0.5% of like crypto mind share. So just to quantify that idea a little bit. One thing I also just, Sreeram, you talked a good bit about these decentralized services, the AVSs and the NCNs that are making use of the security that restaking platforms provide. That's always been, I guess, a big question for me, at least, is EigenLayer drew 14 billion, I believe, in deposits, like a really large amount. Lucas, you can correct me if I'm wrong. I think Jito is somewhere around 180 million right now in deposits. And a lot of those deposits are people who are hoping that these AVSs, NCNs can be, profitable businesses that then pass yield back along to them. So, Lucas, I'll throw this to you first, I guess, but just put simply, like, can these NCNs actually make money and make restaking make sense from a business perspective?
For sure. I think it's, how do I say this? Like, the easiest way to do that is to find protocols that are already live today that are like, maybe they're thinking about adding staking, or, basically protocols with like PMF where you can get them to launch on the restaking platform is like kind of approach that we've been thinking about. And like the Jito tip router goes live on January 30th. Hopefully there's no delays there, but that will generate, I can't remember. There's a forum post on there that kind of runs through some numbers. You can do the math in a spreadsheet, but it's like pretty significant rewards. And I think like there's a bunch of other protocols that are live today that are building on Jito restaking that have product market fit. I think that the one thing that like we've thought a lot about is being careful about how much capital is put into the protocol. There's been, ever since deposits launched a few months ago, even up until today, there's been caps in place. There's one cap, like unlimited cap raise for a 24-hour period, and TVL like doubled or more than doubled. Right now it's like around 110 million TVL, I think, which is much, much smaller than what EigenLayer has. But the kind of want to like, our thought process has been trying to find the equilibrium on kind of the way up on TVL, instead of like, no caps, just deposit everything, and like finding the equilibrium like on the way down. I kind of just like let the market figure it out at some point and see what happens.
So one thing I'm curious about, and this topic comes up quite frequently, especially on crypto Twitter, where people don't quite understand how the technology works, or perhaps not interested in how it works. But one thing that I get asked is, okay, what does this actually enable? Why should users care? Why should I care about this as a user? And so I asked to both of you, who are arguably the best people to ask this, what can I do with restaking as a user? Why should I care?
Okay, I'll go first. As a user, you should not have to care. I think that's my answer. And what is the user touch points to restaking? You can stake and get rewards. I think that's an obvious one. But that's not the most interesting or important thing that we're trying to do. We're actually trying to get people building these AVSs, which I think of, I was just explaining before, that these are autonomous verifiable services. They run on their own, they're verifiable. And who's this for? This is for application developers. This is not for users. So application developers come in and they now have an array of rich, powerful services that they can rely on, which don't have to all run on top of a blockchain. They're all running on their own consensus networks. And you can call them with a measurable amount of security. What might these services look like? We have 100 plus new networks building on top of EigenLayer in various stages of development. And these services do a variety of things, like standard things that a lot of crypto projects have been doing before, like bridging, like oracles, like MEV management. But they also do lots of things that have never been done before in crypto. Proofs of location. I want to know like where a user is, and a protocol wants to measure online where they're logging in from. web proofs or zk-TLS. You want to prove to a blockchain what you have in your private login on your Uber. I have a 4.9 driver rating on Uber, and I want to prove to a blockchain that that is actually true. How do I do it? So we have a category of services called zk-TLS, opacity, reclaim, or examples of that. You want to, let's say, run a multi-party computation. I have a complex computation that I want to split and run so that no one node ever gets exposed to all the data, but the computation is done correctly. Secure multi-party computation, we have infrastructure services like Silence protocol building secure multi-party computation. I can call from inside an app, say, collect the secret on the network, do the computation, give the result, and take an action on chain. We have fully homomorphic encryption. You want to run computation directly on top of encrypted data, and you get the outputs. We have AI inference. I want to run all this, stories people tell about AI autonomous agents. None of them are autonomous because they can be stopped. They run on a server. They're not verifiable. Can you run them on decentralized networks that keep running forever? They're autonomous. They're verifiable. Inside AI agents, there's like lots of sub cases, like, inference, training, data, models, benchmarking, GPU networks, right? We can go to each of these are big categories, and there are subcategories for each of them. In Ethereum, there's the category of rollups, like, can you get fast finality on rollups? Can you get bridging on rollups? Can you get, censorship resistance? Each of these can be different services. So we have a proliferation of like a category of service. Let's say you want to build Filecoin, like a storage network, and you don't want to use an existing network for whatever reason. You have specific functionalities that you want to build. You can build that on top of EigenLayer. So this is the category of complex infrastructure services that is being built on EigenLayer. And one of the reasons, Jack was saying earlier that the narrative on restaking was very high like 1 year back, and now like nobody cares about it. It's actually great nobody cares about it, because it's the right thing right now. People extremely overestimate what can be done in the short term and underestimate what can be done in the long term. And as these services are built and mature, these are very complex, hard services to build. They take years to build and mature. Each one is of the similar complexity of a layer one. And so as these services get built and frameworks for app builders to integrate and use them manifest themselves, that's how users will experience it, is as part of their application development. This is built into our app development thesis for crypto, which is, I think crypto app development is very much like web application development in 1995. Right now, you have like fixed small frameworks on top of which you can build. But if you need anything powerful, you have to write your own, roll your own server, roll your own chain. Instead, in 2025, like the way you would build web applications is you have the cloud, you have a lot of SaaS services, each of which give powerful guarantees, and you just mix and match them to build your application. And that's our vision. That's what AVSs are. Each of them are like permissionless SaaS, verifiable permissionless SaaS, on top of which application builders can just mix and match them.
So just one quick follow-up to that is, I would imagine you might disagree with this, but some out there argue that when it comes to like crypto infrastructure, all this stuff over the long run gets commoditized because there can be multiple solutions to one thing. And so just market forces make it so that they're not really money-making enterprises. Obviously, there are lots of B2B software companies out there just in general, but I don't know, like when you look at a lot of the AVSs, they're, like you said, not really user-facing. They're kind of, a lot of them serve kind of niche use cases. EigenDA is a pretty big use case, but I don't know, like, do you think that the, do you foresee crypto infra getting commoditized? And is that a threat to EigenLayer's ability to kind of produce this economy?
Yeah, I think as long as the only thing that matters is narrative, these infrastructure which are not consumer facing are not going to be highly valuable. As long as actual value matters, which is where I hope we're all headed, then these will be highly valuable. In the last 20 years of venture investing, the biggest category that venture made money on is software as a service, all B2B. The reason it's much easier to bet on SaaS than it is to bet on a new social network is when you're betting on SaaS, it's somebody building a narrow horizontal service. If you want to know who's the best to build like a streaming data service for autonomous vehicles, it's very easy to find like which is a top team to go build it. If you want to know who's going to build the next social network, you're tossing a coin like, with a 1% chance of winning. So it's much, much easier to actually take concentrated bets on like who will win each of these categories, as opposed to taking bets on like this blob of what is, which particular social network is going to win. So I think, as the industry professionalizes and matures, it is not going to matter the stories and narratives of like, hey, it's consumer facing and I remember some token number and therefore like that is going to go up, that hopefully goes down, and real actual measurable value where like each of these units contribute additional units of value. And the other thing I hear is, oh, if the value gets split across like 10, 20 AVSs because you're using each of these modules, then like, how does value accrual occur? Every non-crypto web app uses 15 SaaS services in the backend. And there are hundreds of unicorns in SaaS. So that's how it works. Like each of them specialize. In fact, this is the arc of civilization. The arc of civilization bends towards more specialization. Each of us specialize in something that we do really, really well and supply it universally. So I totally counter this thesis of like they don't have value accrual. I think this is the only thing that will be valuable in the long run.
Cool. One thing I want to touch on quickly, probably won't be that quick actually, but Eigen obviously does restaking on Ethereum. Lucas, Jito does it on Solana. Are there any big differences here? People already don't understand the differences between any chains, but this is very complex. So what are some of the big differences that actually maybe matter more than others, if there are any? Maybe Lucas, let's start with you.
Yeah. I think that from my point of view, a lot of the Ethereum use cases for restaking are kind of built around scaling Ethereum or scaling the L1. There's some other stuff that he was talking about in there, like the AI agents and zk-TLS, that maybe that necessarily isn't true, but seems like there's a lot of focus on scaling the L1. And I think on Solana, the use cases that we see more of are kind of like more like not necessarily on scaling the L1. It's like running services on top of the L1 and like inside the L1. So maybe it's like a Keeper or an Oracle or some like MEV network or like just kind of like networks that you're not necessarily building them with the purpose of like moving compute off chain. It's more about like adding trust and security and kind of like providing a carrot and stick for services. I think another benefit of restaking on Solana is just the like super high throughput and low fees. So I think that like some of the LRTs, like when they want to pay out rewards on Ethereum, they've spent like hundreds of thousands of dollars doing that. And on Solana, like you can do the same thing for like probably like less than $1. So there's just like way more that you can actually do on Solana, which means that a lot of it is more composable and fast and low latency. Like for tip router, it's running the entire like consensus engine for tip router runs on Solana. So like you're uploading Merkle roots and running cranks, and there's like 100 transactions or something where, on Ethereum, that would be super expensive. So then you have to think about getting stuff onto L2s, or maybe you have to think about like off-chain compression or verifiability, where in Solana, it's just like, let's just like put it on chain and make just crank it. Trying to think if there's anything else to add. Yeah, I guess like there's that, and then maybe this isn't necessarily true for Ethereum versus Solana, but one of the things we felt strongly about in the beginning was that you should just be able to support any token to get restaked. So basically, you could do Sol, you could do LSTs, you could do like Trump or Bonk or anything else. So yeah, I think there's definitely like some advantages to doing it on Solana.
Awesome. Yeah, I'll speak to some of the points there. EigenLayer also moved to permissionless restaking as of 3 months back. So any token can be staked. It has to be an ERC20, but that's on the other stuff. I think there is some because many of these services are in various stages of development. I think the service that many people know about is EigenDA, which is a scaling service, and so this already speaks to a little bit of the point that Lucas is bringing up here, which is Ethereum doesn't have enough throughput for all these services to run their consensus, publish their data, all this stuff on a certain place. So one of the things we had to do, and Lucas has the luxury not to do, is that we had to build a hyperscale DA and keep scaling it, because the only way, to zoom out on it, what is staking or like restaking or this kind of like a protocol like EigenLayer doing is providing crypto economic security. It's promising that these group of stakers are put this money at risk, and if something goes wrong, they'll be slashed. But to provide that ability to trigger slashing, the data field, the data inputs that are going into that service need to be public and open. Only then anybody can read the data and say, hey, that guy said he did it, but he actually didn't do this. So I can trigger slashing only if the data is available. So data availability is a requirement. So hyperscale DA is a requirement to actually run like, an AVS ecosystem or service ecosystem on top with crypto economic security. And so we had to build DA because Ethereum didn't have throughput. Other than this part, the scaling that EigenLayer services are for scaling is not at all true. Like most of the services have nothing to do with scaling. They're all like totally new, radically. In fact, I would say many categories are invented on like EigenLayer. This includes things like I want to add a compliance layer before I do transactions on chain. We have Predicate, which is building that. I want to do a security layer, like which screens transactions before hitting on chain, like those kinds of layers. I mentioned zk-TLS. I mentioned fully homomorphic encryption, secure multi-party computation, trusted execution environments, proofs of location, proofs of identity, all kinds of things, which have really nothing to do with what a core L1 offers. But another thing which is really true that Lucas touched upon is the cost of writing some of these consensus messages to L1 is a huge pain for Ethereum, right? It's just a problem in Ethereum, and we all have to acknowledge it. Like each of these networks, so we have to do, for example, our consensus protocols, all these AVSs use BLS signature aggregation to make sure you're only writing one signature, not writing 100 signatures, because Ethereum doesn't have space for it. So there's all these things that add additional work for actually creating powerful services. But we think because in the Ethereum ecosystem, these are necessary at like a necessary additions, the value add that we are bringing as EigenLayer is larger relative to like, oh, anybody can already build and deploy service natively. The value add that, like a restaking protocol can do is smaller. So, the bigger the problem that you solve, the bigger the market value that you can acquire based on that. So both of these are true. There's a lot more pain, a lot more chewing glass on building an EigenLayer AVS, and hopefully Jito is easier. But I think that's how I see it.
Cool. So none of you actually answered my question, by the way, which is how do they differ on Solana and Ethereum on an actual technical level? But that's okay.
Before you were here, we talked about native restaking and how you withdraw credentials and all that stuff.
Okay. Well, that's good. Well, okay. You talked about one thing I want to touch upon, which is EigenDA. And the way I want to frame this is, we're on Solana. We're clueless about DA. We don't know what that is. But a lot of people in other ecosystems rely on DA pretty heavily to scale. But it seems like there's perhaps multiple players in that. There's you guys, there's Celestia, there's Avail. I think there's maybe a few other ones. How does one think about, as a, let's say, a consumer or a customer of DA, how to differentiate between those? Where does EigenDA fit in the grand landscape?
No, I think like we're obsessive about throughputs, kind of like Solana. We have been on mainnet at 15 megabytes per second, and Celestia did a bunch of upgrades to now get to 1 megabytes per second. So you can just start with throughput. I think that's the only reason we exist, is we want to scale, and our goal is to get to like tens of gigabytes per second. Otherwise, we're not cutting it. So we did an experiment, all chains fit on EigenDA back in September, I think, where basically we crawl blocks from every blockchain. That includes Bitcoin, Ethereum, Solana, Celestia, everything that we could get our hands on, and then fit it on EigenDA. The fun experiment is what we found was 90% of all blockchain throughput is in Solana. It's kind of you guys maybe already know, but it was interesting for me to experience that.
And the website is still up, right? You can still see. It's a pretty fascinating experiment to see the percentages, but
yeah, we are not. I mean, it just takes cost to keep running the crawling and writing data to so much throughput to DA without anybody paying for it. So we stopped running it, but there's an archive where you can actually see it. It's eigenda.wtf. So in terms of how you think about so firstly, what is DA? DA is, when you think about a blockchain, you need read assurance and write assurance, right? You need the ability for anybody to come and read your data from your system, and you need write assurance, no censorship. People should be able to write to the system. And when you think about read assurance for things like layer 2s, the best way to get it is to write to the layer 1, because that's what a layer 1 does, is assure that you can read and write, or both write to it and read from it. But if you are using an outside, like, I'm using my own committee, or I'm not using Ethereum, then this layer needs to have a very high grade read assurance, right? Because I'm publishing all the layer 2 data on something. Only if other people are able to read it, they can continue running the layer 2 or challenging the layer 2 on like incorrect state updates. So that's what a DA does. And the parameters that we think a lot about are, number one is throughput, and number two is security, which is how is security of this ecosystem work? Is it coming because of stake? Can the stake be slashed? What is the repercussion? All this stuff. So that's how I would grade like different DAs on: number one, throughput; number two, security. And EigenDA is particularly built as an auxiliary DA. So the funny thing is, actually, like something like Celestia or Avail are actually just layer 1 blockchains. They're just layer 1 blockchains which you can build execution on top of. Whereas trying to build a layer 1 blockchain puts a lot of additional constraints on what sets of things you're doing. Whereas what EigenDA does is purely just does TA. It's a network which doesn't have consensus. It's not an ordered ledger by itself. You can write, anybody can, it's a self-leader protocol. There's no leader in block proposer or anything like that. Anybody can take their data, encode it, and then write it to the nodes in EigenDA. So, and as long as you get enough nodes to give you a certificate that they received their chunk, it's horizontally scaled. No one node ever downloads all the data. It's fully horizontally scaled. So if there are n nodes, each with 10 megabytes per second bandwidth, you can theoretically get up to n by 2 into 10 megabytes per second. So it's a extremely scalable DA solution. And it doesn't arrive at consensus at all. You just get these certificates. You're holding them off chain. You can write them back to Ethereum, and then you can order them, right? You're only writing the certificates on chain. So that's how our system works. It's actually ridiculously simple. Uses KZG polynomial commitments, which is the Ethereum roadmap of donk sharding, but it's already at 10x higher than where donk sharding will be in like several years. but we want to scale this to its theoretical limit, hundreds of gigabytes per second. So that's how we think about EigenDA. Every AVS should be using this if they want to claim crypto economic security, because you have to write in a DA that actually you can read, anybody can read from.
One question around that last part, because I'm ignorant. You just said dank sharding, when it goes live, it'll still be less than EigenDA.
That's
correct?
As far as what their current parameters, I mean, as you know, Ethereum people are fighting about like what the roadmap should be and how fast it should go. And, I think all of us here agree it should go faster than you can imagine. But but that's Ethereum's roadmap as of today is scheduled at a few megabytes per second. And we're already at 15 megabytes per second, and we'll at least scale 10x in the coming year.
Right. And so I guess the natural question then there is, play those two scenarios in mind. One is if dank sharding does not change parameters and such that EigenDA is much more performant, then why would anybody use regular native dank sharding as opposed to EigenDA, and vice versa?
Yes, I'll explain that. I think the full security of Ethereum is sitting behind the native DA, right? Like dank sharding. And what do I mean by the full security? Imagine if a majority of Ethereum block producers produce a block, but the data was unavailable. Then Ethereum will fork around that fault. So that's like a majority fault on Ethereum's part, and Ethereum will fork around that part. Now imagine the same thing happens on EigenDA. A majority of block producers on EigenDA were faulty. Now Ethereum's not going to fork on behalf of a fault on EigenDA, because that's not a part of the Ethereum's consensus. So you get higher security if you're an ETH-centric rollup. You will get higher security on top of if you use dank sharding, as opposed to if you use an out of protocol DA. Now, is it possible to build new kinds of rollups and other structures which are EigenDA native? And the answer is yes. And so those will fork with EigenDA's faults, but you can't bridge ETH into it. So there's these really technical kind of nuances. But if you want to get the full security of Ethereum, you have to use the native DA. If you wanted to get the full security, is the similar security of Ethereum on EigenDA, you can do it, but you can't do it by bridging ETH into it. So that's how the whole topography would split up.
Yeah, that's a good overview. That I'm sure our listeners might not be as in the weeds on that. So that's some in-house issues on Ethereum. Lucas, I want to do some in-house issues on Solana. Multicoin just put out its proposal that would potentially cut Solana's inflation, in part, I guess, by reducing the amount of Solana that's staked. Now, Jito has a liquid staking token, and then obviously restaking requires tokens to be staked. So I don't know. I guess just in general, what are your thoughts on the multi-coin inflation proposal? And were it to pass, is that something that's kind of actively bad for the business model of Jito restaking?
I don't think so. I think that if there is enough if there's enough rewards to earn in restaking, then people will go to it, and the market will kind of decide what happens. I think I'm in favor of reducing the inflation and making it, well, I guess I'm in favor of making it a more intelligent parameter, where it's not just you throw a dart at a dartboard and choose that, and then you throw another dart, and that's how much it goes down every year. There needs to be something that's more thought out to what is inflation used for, and should we reevaluate it and make it something that's more reasonable and more thought out, versus some parameters that people chose and never kind of looked at again. But I need to read their specific proposal and the parameters that they've kind of chosen more in depth and reason about it a little more. But I mean, Yeah, if Solana, like I think the stake rate is pretty high on Solana. Maybe Mert knows what it is off the top, but I think it's like 70 or 80% or something. Like 10% of that is LSTs. And so like you could still see a really large drop in the amount of assets staked and still have like a pretty good amount in LSTs. And we don't necessarily like need that much security. Like capital is kind of a commodity. And so yeah, I think the like if the rewards are there, then people will come. And yeah, I think it's a good proposal.
Lucas, first, do you believe Tolly's philosophy that economic security is a meme?
I mean, if he believes that, then like, why does Solana have staking?
Like, so, I'll take it as a no.
I mean, there's a lot of protocols that like have staking in some form. Like you obviously have proof of stake blockchains, like those rely on economic security. I think his thing is like, as long as like Circle has a copy of the ledger, then like they like won't respect redemptions, or I can't remember what his exact argument is, but I think we'll like Solana doesn't have slashing yet. I think there's been some points where like Ethereum has slashing, and like economic security has been helpful for that. And you also have other protocols like Pyth has staking and slashing, and I don't know exactly how the security works there, but like I think in general I would disagree with Tolly on that.
Okay, that's unfortunate. I was going to get you to debate Sreeram there. Well, in that case, Sreeram, I'm sure you've heard of this or seen this tweet multiple times about what Tolly's saying. I can probably steelman it. Something about basically there's many other costs below economic security where you can actually get the same thing. And so
I can both steelman it and take the counter view. So I've fought with Tolly many times on this, so no issue with that. The point is, okay, here's a view, like, we're saying that there is whatever 100 billion staked in Ethereum, but really is 100 billion, like, is that the damage to the stakers, because they're delegated to operators and operators don't put their own money. And so really, is that the cost that is an adversary has to pay? I think this comes from like an old view of crypto economic security, and which is that you reason from an adversary's viewpoint. An adversary's cost to attack is the amount that you can get slashed, and the adversary's benefit is how much money you can steal. So you have cost of corruption and profit from corruption, and then you reason it for an adversary. But the problem is adversaries may have all kinds of extrinsic incentives. They may have a short position on Sol or ETH or whatever, and they may not actually be the delegates. So both the profit and the cost are not reasonable to actually like calculate correctly. So I kind of agree with Tolly on that this is actually like the crypto economic security is based on this thesis and therefore like insufficient. So in fact, we created this thesis of what we call strong crypto economic security. Strong crypto economic security says, I don't need to reason about like adversaries. Like I need to reason about myself as a user of the protocol. And I should have some measurable guarantees from the system. And the way it works is, instead of like normally slashing refers to slash the money and burn it, right? Which is indiscriminate like spend. Instead, if you slash the money and then redistribute to the harmed parties, that's a protocol. Slash the money and redistribute to the harmed parties. The protocol should have a way of knowing who the harmed parties are by, for example, them acquiring insurance a priori from the protocol that if something bad happens, they will get paid back. And so then what happens is you don't need to know whether it's a delegate or like some staker or operator. You're not reasoning from the adversary's viewpoint. You as a user of the protocol have this insurance that if something bad happens, you will get compensated. Now, if the staker and operator are in a relationship where like staker is delegating to an operator, you don't give a shit about it. You're using the protocol, you get security and safety just because you're insured. So that's my answer to it, that there is much, much better ways of doing crypto economic security. It is not what is being done today, either in Ethereum or anywhere else. But EigenLayer is building it. We encourage other protocols to build this thing, and totally understood this, and he calls this insured computing. That's kind of correct, right? It's insured rather than just crypto economic security.
That was a really interesting overview. I guess to continue down that road, Sreeram, slashing, as you said, is part of the security considerations here. To my understanding, EigenLayer has put slashing live on testnet, but it's not yet at mainnet. I guess just like what were the considerations of why it took so long to get slashing enabled, and I don't know, what are the risks that are introduced as you do
Yes. That? Okay, great question. Slashing is one of those things which is like, if you want to just build slashing, it's really easy to do. In fact, our first version on mainnet had slashing just turned off. Because what is slashing? Just say burn the money, right? It's a command that says burn the money. Like that's what slashing is. And so who issues the command? What is the timing? What are the considerations? How much of the money is burned? A lot of the complexity in slashing is the balance of powers across the marketplace. Are stakers more powerful, or the AVSs more powerful? Who has like tight guarantees from the protocol? These are the hard things to reason about. And so our original slashing model was, when I stake like $1,000 and then I stake into 5 AVSs, any one AVS could slash my entire $1,000. That was our original model. Our new model, which is what is going live now, is already on testnet and is going live on mainnet, is I stake like $1,000. I specified what proportion, what fraction of it each AVS can slash, and the total sum is less than 1. So what this does is this means that I'm attributing like a portion of my stake to each one of these AVSs. So there are lots of trade-offs in between these different designs, and I don't think we have time to go into that. But understanding how the different sides of what are the value propositions for the different sides of the marketplace, making sure we're building to those value propositions, making sure we have enough expressibility in the protocol for whatever sets of things people want to build. That's what took us a long. It's the design that took us a long time. Of course, in smart contracts on Ethereum, like we have this problem that it's almost like building. It's the shipping cycle is closer to a hardware, chip tape out type cycle than it is to a software company 2 months like ship and iterate cycle, because of all the audits and rigidity that you have to build into the protocol. So which is one thing like we hope to improve over time, but that's where we are. Like, it's the design that took a longer time, and I think we're very happy with where we landed there finally.
Before we close out, I want to ask some fun questions. I mean, I think they're fun. 2 questions. 1, how do you explain restaking to your grandmother? And 2, what does everybody get wrong about restaking? And let's start with Sreeram.
How do you explain restaking to your grandmother? I don't want to explain restaking to my grandmother, but I'll explain EigenLayer to my grandmother. And the way I explain it is, over the last 70 years, technology has accelerated massively, mainly because of one reason, which is venture capital. Venture capital is somebody else brings money, somebody else brings ideas, and they work together in order to create productive enterprises. Otherwise, you need a double coincidence. The guy who has a lot of money also needs to have great ideas, and that doesn't happen. The same thing is true with trust and innovation. If you want to build some product that everybody trusts, you have to be trusted. This is a huge pressure point. If I have to build a product that everybody trusts, I need to be trusted. So I need to be both trusted and have great ideas. Instead, what we do with EigenLayer, with I think a lot of the crypto systems, is to separate who brings innovation, who brings ideas and code, and who brings trust. By creating a layer of trust that anybody can innovate on top of, now you can be a nobody, you can be an anon, and sitting in Indonesia, a kid, 15-year-old kid in Indonesia can build a product which competes with JP Morgan here in the US. JP Morgan had that advantage that they are trusted, but this kid doesn't need to be trusted because the blockchain underwrites, EigenLayer underwrites trust for all these services. So that's how I explain it to my grandma. Number 2, can you remind me again?
What does everybody get wrong
What does
about
everybody get wrong
restaking.
about restaking? Restaking is not about restaking. Restaking is about building new and useful services. And these services supplant applications. These services are not consumer facing. So people are disappointed that, oh man, EigenLayer is live for so long. I don't see any. It's not for you guys. The consumers use apps. Apps use AVSs. AVSs use staking. This is a huge level of layers on top of layers, but that's really how these that's how the cloud works, that's how we work. So that's what people get wrong, is they are expecting to have a consumer interface for fundamentally an infrastructure product.
How would I explain restaking to my grandma? I think I would just say it's like a savings account. I can't explain that to her at all. The second question, what do people get wrong about restaking? Obviously, we're going in the weeds on this podcast and going super deep into details, but I think people just get confused on restaking and it's just staking. There's nothing that fancy going on. Obviously, well, there is behind the scenes, but they don't necessarily need to know about that. It's just staking. And yeah, I think also to echo his point, it's not the user facing side of it. Maybe they use products that use restaking behind the scenes, but they're not actually interfacing with it directly. So yeah, if they're using a multi-sig policy network or something, maybe they're using it behind the scenes, or soon they'll be getting airdropped MEV tips in their wallet from the Jito tip program, and that, that's been going on for a while, but they don't even care how that's done. User, but it's the restaking is powering that. So yeah, I would say they don't necessarily care about it. It's a platform protocol, so it mainly interfaces with the applications and the infra teams that are building use cases on it. And then I guess we're kind of in a unique-ish position where people can launch vaults using Jito restaking, but they're not necessarily interfacing with Jito directly. They're just getting the various VRTs and putting them into DeFi and whatnot.
Yeah, and one other thing I just wanted to, I had meant to ask about earlier, Lucas, before we hop up out of here, but is there a world in which Jito enables slashing before Solana itself does by means of restaking?
That would be funny. Yeah, I think we kind of went down some of the same rabbit holes that it sounds like EigenLayer did with slashing. We kind of took the other approach, where it's let's just make it open, and there's no right answer to slashing, and let's just let people decide how it should be implemented. And then you start thinking of all that weird edge cases, what if the vault is malicious, or the NCN is malicious, and there's just a lot of edge cases. So we actually, I think, just commented it out before we deployed it to mainnet, or before it's deployed to mainnet. But yeah, it's we'll see. There's a chance that it's deployed before Solana.
Interesting. Well, cool. Sreeram, Lucas, thank you so much for coming on. It's been a really interesting conversation. You both have a lot of just kind of cool stuff coming on the pipeline with restaking. So yeah, again, really appreciate you both taking the time.
Thank you so much, Jack. Thanks, Lucas, Mert. Really glad to do this podcast and look forward to more interactions in the future.
Thanks, guys.